Dear friends, today we will learn how to prepare a boundary condition for RSM-ROMS model. So we will be using R2 NCEP R2 data, which is available from 1979 to 2019. So first you need to create an account in this NCAR website, and then if you search for R2 data, it will be available here. So NCEP DOE R2 reanalysis data. So we'll be converting this data into P2SIG files. If you have created an account, you need to sign in. Then only you will be able to access this data. You scroll down, download, and then you can download pressure level vertical analysis data. So go to the web listing files, and then it will go complete file list, and the data is available from 1979 to present. You can directly download, or you can use script file to download this particular data. So we will be showing here a specific example. My task was to convert these R2 data into climatological average 6-hourly average files, and then convert into P2SIG files, and then run RSM ROMS model. So the steps which I follow, this example is normal. It's your choice whether you want to convert into climatological files or simple same file you can use to convert directly into P2SIG files. So to do that, first we downloaded all the data. So our downloaded data is available in our server. So if we go to GRIB tar files, this is the data which I have downloaded from 1979 to 2014. So if you go to 1979, these are the GRIB files, and the variable which is available in these GRIB files are 12 variables, which are sufficient for at every 6-hourly interval. So each year has 1460 number of files, and leap year will have 1464 number of files. So the first task for this particular problem was to average, to do the climatological average. So I use a script, CDO command, to average all these year file. I'll be giving you some idea of that script. The script is available in this directory, and to do the climatological average, this is the average _ clm.csh script. If you go into this script, this is a very simple script. Basically, it is a CDO ensemble command which average out all the GRIB files into a single file. So to give you better understanding, so this is our data directory which I have assigned with D, and this is our output directory. Okay, and I have prepared a list because once you average out, the information of date and time will be lost from the file. So you have to specify that particular file, which particular date and time you want to assign to that particular file. Okay, so I have if you go to another terminal and open what is list 1980, so this includes file names, year, month, day, and the hour, and this list is up to 1464. I have selected 1980 as a leap year because once you have climatological average, how do you average the leap years? So this particular 1980 as a leap year will have 1464 number of files, and we will force average file date as a leap year date. Okay. So so this is 1464. So we have read this file, and in this we are extracting 13 to 80. So this is 13 to 18. So basically we are extracting this information. The year we can replace, but this information is crucial. Okay, month, day, and hour. So we are extracting that information from the list 1980, and then we are defining a variable T1 1464. You can choose any year, the boundary condition for that particular year you want to prepare. If you selected 2003, or let us say 1988, it will have, okay, it will have a leap year files in it. If you okay, if you don't select that particular leap year file, the February 29 day will not be there, otherwise it will be there. So this CDO ensemble is reading year 1. Year 1, we have defined a list again. If you go back and do list, these are the year which are 36 in number. So 1st January 1979, and again 1st January 00 hour, and again 1st January of 1980, and so on until 2014. You need to average out those files. So this particular will average that 1 year, 2nd year, okay, 3rd year, and 4th year, and so. And MD1, what is MD1? MD1 is the day. So we are extracting the day information from this list file. We are assigning over here, okay, and this particular thing will go for a 1 day. Like, let us say, to be more clear, let me open this file. So let us say for a single file, so this count T1, the loop will go from 1464. So this will keep on going in a circle. Okay, so for T1 equal to 1, the file name, this is the month, day, and year. So it will average out all the 1st January 00 hour file, and then once CDO command do averaging, these two will do averaging, and this one is for leap year files, and this is for not a leap year file. Okay, the same command, CDO ensemble, and all file names are separately behind it. So this is a very simple script. Just arrange all 36 years like that. There are better ways available, but this is what I found as shortcut. Otherwise, you can also do loop for averaging out for all the years if those years are more than. But anyway, so once you do averaging of all the data, we are forcing the date. So this forcing of the date script is available in RSM libs etc files. So you need to first install RSM model into your server to be able to use this particular script to force. This is the output file. So you need to force in all the files date. So that year which you assign, let us say you are doing run for 1988 year. So that year, month, and day for that particular file are being forced to change in this particular file. Once you do that, your climatological average file will be available in this, will be stored in this. So let us go to this directory. So once you go, so we have converted, there are many other years I have changed, but let us say for 1988. So this is the climatological file, wgrib. So this has all the variables and the date is forced to 88 in this manner. So once you convert your climatological, this particular file is same as the format and the variables are same as your any yearly file. Okay, but since this is a climatological file and those are instant that for that particular hour file, that is the only difference. Now my task was to convert this GRIB file to P2SIG files. For that, okay, for that I went to P2SIG. So it is easy step. One was that one script. The second script is we have converted from GRIB to P2SIG file. So to convert this into P2SIG files, this is the script. So what it is doing, it is taking data from this directory, from the GRIB files, and it is using RSM model script from this, and it is dumping all the converted P2SIG files into P2SIG folders. Okay, so what we need date and time. Let us see what list of years we have read, and that particular year we want to change. Okay, 1988. Okay, so this is the only command. This is the utility available in RSM ROMS P2SIG. If you use this command, and this is the climatological name which we have given for that particular file, you just place it here, and then this is GRIB file, and what name you want to define into P2SIG files, and then you have to define this important step, which include the year, for which particular year this file is, the date, month, date, hour, and so. If the because if it is 006 hour should be 00. If it is 06, hour should be 06. So this is a counter for the date time values, and this is extracted from the file itself. So all these month, days, and time are extracted from the file itself. Once you run this script in the loop for 1464 step, it will change all the GRIB files into P2SIG files, and there is nothing else that you need to do. And the data is stored into this directory. So these are R2 climatological files, and then you follow my other YouTube videos how to use this P2SIG files into RSM ROMS model. Thank you for listening.